All right, so today we're moving into a new unit. This unit is on functions. And before we can really talk about what a function is, we need to talk about what a relation is. Now, when we're talking about a relation is really any set of ordered pair. So a relation is a set of ordered pairs. What are ordered pairs? Well, those are those x, y coordinates. And what makes them a set is that they have things in common. So if I had a relation that was like -1, 4, 0, 6, 5, -2, this would be considered a relation, right? Something is in common between these different sets of numbers. Um, and when we're talking about ordered pairs, the first number in an ordered pair would always be what we call your x value. And the second number would always be your y value. And you've seen these on graphs, and you'd be able to graph each point within this set of ordered pairs. Now, more often than not, a relation has something being done to it, but we don't really need to get into that in terms of where we're trying to go, which is functions. One thing you should know when we're dealing with relations or functions is that the domain of the relation is the set of all of the x values, the set of x values. So for this set of ordered pairs right here, the domain would be -1, 0, and 5. And the range of this relation is the set of y values. So in this case, our range would be 4, 6, and -2. Now, a function, the difference between a function and a relation is that a function, let me scroll on up here. A function, which is what we're talking about for the next quite a while. That's our next unit. A function is a relation that has a relationship between the values. So something's being performed on these values, right? So with a relationship, where each input has only one output. A lot of times in math, they like to talk about functions as being machines, like function machines, and you'll see so many types of machines that actually are functions. Like if you think of going to buy gas, you have a set price for gas, right? And the variable is how many gallons of gas you get. And no matter what, the relation that's being performed on that is however many gallons of gas you get are being multiplied by the cost of that gas per gallon. So if I have 5 gallons if I have gas that's $5 a gallon and I get 6 gallons, right? I would have 6 times 5 and I would get $30. And no matter what, anytime I got 6 gallons of gas at $5 a gallon, it's going to cost me $30. That input of 6 is always going to give me the same output of $30. The only thing that can change is my input, right? So if I had a different, say, number of gallons of gas, say I only got 2 gallons, well, then it's going to change, right? I'm going to have 2 times $5 a gallon and I would get $10. But every time I got 2 gallons of gas, it would cost me $10. So every input, the input we have is how many gallons of gas we're getting, and the output is how much it costs. And so each input can only have one, I forgot to put the 1 in there, one output. And that is the biggest rule when it comes to functions, right? And there's different ways to determine functions. And that's all we're really going to talk about today is the different ways to tell if something is a function. And then you will have an assignment for that on Delta Math as well. So if I have a function, or I have a set of ordered pairs, we want to know, is it a function? Right? And it's just going to be yes or no. Is it a function? So if I have something like a set that is, let's say 5, -2, or we'll go 5. Yeah, 5, -2. 3, -5. 2, -5. 0, -2. And -1, -3. When I have a set of ordered pairs and I want to know if that set of ordered pairs is a function, all I want to do is I want to look at my x values. So here I have 5, 3, 2, 0, -1. If none of those x values repeat in a set of ordered pairs, yes, it is a function automatically. Yes, it's a function. If I were to have a set, for example, -4, -1, -3, -1, -2, -3, -1, 0, -3, and 2. So this is my set of ordered pairs. So I'm going to look at those x values, right? If I look at my x values here, I've got -4, -3, -2, -1, -3. My -3s repeat. And that could happen in a function as long as they have the same y value. If they have a different y value, it can't be a function. So if we look here where it's -3, I've got a -1. And if we look here where we have a -3, we have 2. Those are not the same outputs. They're not the same y value. So this would not be a function. Right? So this is one way to determine whether or not something's a function. If I have a set of ordered pairs, if the x values don't repeat, I don't have any repeating x values, then it is definitely a function. If my x values repeat and they have the same y value, it can still be a function. But if the x values repeat and they have a different y value, not a function. The other way we can represent functions and relations, for that matter, is tables. And you guys have seen tables presented a lot. I wonder if I can make one on here. I probably can, but I have no idea how problem solving workshops. I don't know how to work that thing, but I can draw one. So if I have a table, and you've seen them a lot probably in the past, and they have X, Y values represented, and say I had 3, 5, negative 1, 0, 0, 1, 2, 2, 3, 3. If I look at this table, notice that they're X, Y values. It's just another way of representing a set of ordered pairs, right? My first ordered pair is 3, 5. I could write it like this. Here I have negative 1, 0. Well, I could write it up here, negative 1, 0. 0, 1, right? This is my X value. This is my Y value, 2, 2, 3, 3. So I can go straight down the list of X's to determine whether or not this is a function. I can go, do any of my X's repeat? And our answer on this is yes, they do, right? With 2 3s. Do they have different Y values? This one has a 5 and this one has a 3. So this would not be a function, not a function, right? If the X values don't repeat, automatically a function. But the minute we have a repeating X value, if they have a different Y value, it's not going to be a function. Another way we see these is in what we call maps. If you remember, for each value, so if this is X and this is Y, and I have, say, negative 3, 1, 2, 4, and here I have 0, 4, 7. That 4 looks too much like a 9, so I'm going to change it. Right? And say I have all of these mapped. Negative 3 goes to 0. Negative 1 goes, 1 goes to 4. Let's say 2 goes to 4. And 4 goes to 7. If I have something like this, this is a function, right? I have no repeating X values in here, right? And when I look at what my X values map to, they only have one output. There's nothing in here that maps to more than one of my Y values. Now, 1 and 2 both map to 4, but that is okay as long as 1 only maps to one thing and 2 only maps to one thing. It's absolutely fine. So yes, this would be a function. But what if I had something that looked like, we'll call these my X's, and we'll call these my Y values. They look like, I don't know, pickles. If I have negative 5, negative 3, I don't know where I'm coming up with these numbers. I don't want those numbers. If I have negative 4, negative 1, negative 2, and 1, and here I have 0, 3, 4, 7. 0, 3, 4, and 7. And I was mapping them to each other, and I had negative 4 mapping to 4, and I had negative 1 mapping to 0, and I had negative 2 going to 3, and I had negative 1 going to 7, and I had 1 going to 7. Now, if you notice, none of my X's repeat here, but my negative 1 matches to two different things, right? My negative 1 maps to 0 and it maps to 7. and we cannot have more than one output. So this would not be a function because we've got this -1 going in two different directions, right? It's going to two different pieces, and that would make that not a function. And your entire homework really is going to be, is this a function or is this not a function? The last way that we have to talk about when we're talking about mapping of graphs and functions is graphs themselves, right? So if I have a graph, and we're going to make a crappy graph right now, but the ones that you have on your homework will be good. This would be our y-axis, and this would be our x-axis. And if we were to plot those points, those ordered pairs that we were talking about, they would have to do what we call passing a vertical line test, right? Which means that I could draw a line anywhere through them, and you couldn't get a line more than any one point. So you can see it sometimes. You could see just points plotted on a graph, right? And if none of them are on the same x value, so say I have a point here and a point here and a point here and a point here and a point here, if you notice this, I could connect all of these dots, right? And if I were to drop a line anywhere into the graph of these dots, right, they would only cross in one spot, right? And that's called the vertical line test. So if it will pass a vertical line test, it is a function. If I can draw a vertical line through that graph, it is a function. If I draw that vertical line through and it crosses it more than one spot, not a function. So if I have a graph that looks like, say something like this, say I have a point right here and I have another point right under it. These are both on the same x value. That's two values on the same x. This would not be a function. Not a function is a function. If I have a graph of, say, a circle, right? So I've got a circle somewhere on a graph. If I were to drop a vertical line through this graph, right, it's going to cross here and here. So it is not a function. I'm trying to think of something like this. If I have something that graphs a straight line, right? Anywhere I drop a vertical line in here, it's only going to cross at one point on that graph, right? It'll cross right here. It won't cross anywhere else. So this is yes, this is a function. So this one's a no. This one's a yes. Your entire homework for this week is just determining whether or not something is a function. It will all be on Delta Math. So once you answer the one problem I have here on your Ed puzzle, you could go in and do your Delta Math assignment, and you should get through it pretty quickly. It's all questions about, is this or is this not a function? So good luck with that. Let me know if you have any questions. Feel free to send me an email, and we can hop in a Google Meet and go over it. Other than that, that's all I've got for you this week. So let me know if you have any questions.